Thank you, Rosie. Hello, everyone. As Rosie mentioned, my name is Drago, and the title of my thesis is Quantifying Floodplain Water Storage and the Benefits of Floodplain Restoration for the Lake Champlain Basin in Vermont. So first and foremost, I'm going to talk a little bit about the state of flooding in Vermont, why floodplains play such a major role in the resiliency of floods, and additionally how human interventions are affecting our floodplains. So first and foremost, as we all know, climate change is altering precipitation patterns globally. And specifically here in the Northeast, we're finding increases in precipitation, greater storm events, and more extreme flooding events, and this trend is likely to continue. When our rivers are connected to their floodplains, it allows the rivers to disperse the floodwater, slow the floodwater down, and this creates more resiliency and less flood damage downstream. Additionally, when these rivers are able to access their floodplains, they slow down, the velocity decreases enough to deposit important sediments and nutrients on the adjacent land. So this is extremely important for the ecosystem functioning of our wetlands and other floodplain adjacent ecosystems. Another important factor is when our rivers are able to deposit nutrients and sediments onto the adjacent land, that means, that means that while the river is depositing the nutrients on the land, it's removing these nutrients out of the river system, which can be really beneficial for water quality, especially in the Lake Champlain Basin, where we have high concentrations of phosphorus. Unfortunately, human interventions have reduced the connectivity of our rivers and their floodplains due to human interventions. So here in Vermont, we have very rugged topography, which means the easiest places for us to build our roads are in these flat, continuous river valleys. So as an example here, we see a road and our river at flood stage, and the river is butting up right against the road. When this river is unable to access its full floodplain, that means the velocity of the water is moving faster, as mentioned previously, and we're not able to have that beneficial exchange of nutrients and sediments onto the adjacent land. Also here we see an example of this railroad berm that is running parallel to the Lomoil River. Another case where we can see this area over here that would probably naturally be the floodplain is cut off by this railroad berm, and the river is no longer able to access the full extent of its floodplain. Currently, there's a lack of knowledge about floodplain function in Vermont, and especially there's a lack of knowledge about the existing floodplain storage potential. So when I'm talking about storage potential, I'm talking about the volume of water that our floodplains are able to hold at a given flood. So when we start to try to understand more about how much our floodplains are able to hold and why and how these floodplains might be impaired, we can start to better understand how we can restore these systems and make sure that they're more resilient for years to come. So my thesis objectives are to quantify floodplain storage and understand the controls and limitations on storage in order to identify some restoration opportunities. The approaches I am going to take in order to achieve this objective are to first generate floodplain maps for differing recurrence intervals throughout the Lake Champlain Basin, estimate floodwater storage and assess floodplain storage effectiveness, and lastly, examine restoration scenarios afforded by the removal of berms and other channel obstructions. Today I'm going to be talking about the first two of these approaches. So first and foremost, generating floodplain maps. My research team and I used a low complexity hydrologic model called the height above nearest drainage model, which you can see an example of this in GIS here. Essentially what this is telling us is the elevation above a channel bottom. This is going to act as a proxy of river stage. We also used USGS StreamStats discharge data and land use land cover data in order to create a floodplain mapping model that maps the recurrence interval floodplains for the following floods. For those of you who may not be familiar with what recurrence intervals mean, or the 2-year flood or 100-year flood, essentially this isn't saying that every single 2 years we're going to have this exact flood. It's more of a probability. So we're looking at, there's about a 98% chance that this flood will happen on any given year for a 2-year flood. We used this article here by Zhang et al. In order to base our methodology for this floodplain mapping model, in order to map all of these recurrence intervals for the entire Lake Champlain Basin. So I was then able to take these floodplain maps and use them to calculate our storage volume. And how I did that was I used two different layers. First, a depth map of the river valley, And second, I needed an overlay of our floodplain surface layer, so our floodplain map. So as you can see here, this is my depth map. It is, this is all in GIS, and it's made up of all of these little pixels that are at a 5 meter by 5 meter resolution. Each pixel represents a depth value. What I would then do is overlay our floodplain map layer, and I would take all of the values that overlap between the floodplain layer and the depth map layer, sum up all of those values, and then I was able to do a basic volume calculation using the area of the resolution of the depth raster. So a different way of looking at this would be this three-dimensional cartoon here. So imagine this white blue here is our floodplain map. What I'm doing is I'm calculating for all of the water underneath. And as you can see, our 2-year flood, this is a more frequent flood. Oftentimes, we're going to see there's not as much volume as, say, our 100-year flood, which is going to be our more intense precipitation events. So with that data, I was able to generate this map of the Winooski River Basin. I plan to do this for all of the Huck 8s in the Lake Champlain Basin. So for those of you who aren't familiar with the Huck classifications, our Winooski River, Lamoille River, Missisquoi River are larger basins in the Lake Champlain Basin. Those are all Huck 8s. And what I am doing is my analysis on a Huck 12 level, which are the sub-watersheds within those Huck 8s. So in the future, what I'm planning to do is take this information, because it's all good and great, you know how much volume is stored, but it's important to put this into context. So I'm going to be looking at how much water is actually moving through these systems, so the average annual runoff, and comparing that to the actual storage volume to start to pick out different Huck 12s where we can maybe note that restoration could be used in the future. So, an important thing here, this is for the 100-year flood. I can do this for all of the recurrence intervals I mentioned before. And a way to visualize this is through this plot here. So as you see here, it's our flood volume. And here are our recurrence intervals from 2 to 500. And when we start to look at I have 4 Huck 12 selected here. When we start to look at it this way, we start to try to understand some of the behavior of the floodwater storage over these recurrence intervals. So as we can see, clearly some of these watersheds are able to hold more water than others, but what I really want you to notice is the slope of these lines, because it tells us something interesting about the floodplains. So when we have a steep line like this, it means there's a greater change in volume over the different recurrence intervals. This could be demonstrated by a floodplain acting like this. So here we have our recurrence intervals. Our lighter colors are 2 years, 5 years, 10 years, etc. So we have at our earlier or lower recurrence intervals, the floodplain is able to access, the river is able to access most of its floodplain, but it's not until it gets high enough at the 200, 500-year flood that it's able to jump over the road and access the remainder of its floodplain. A restoration option for something like this would maybe be building a bridge in the road or having some sort of culvert to allow the river to access the remainder of its floodplain. When we see a flatter line like this, we're looking at a floodplain potentially that could look a little bit more similar to this, where as early as the 2-year recurrence interval, we're starting to access the full floodplain. So this is starting to tell us a story about the way these floodplains are behaving. So I'm interested in looking further into this data and looking at these slope values, comparing them with some channel shape data in order to better understand how we can use this to prioritize restoration in the future. So to wrap up, floodplain mapping is nearly complete for all of the Lake Champlain Basin watersheds. Floodplain mapping enables us to calculate flood storage across recurrence intervals. And the variability in recurrence interval relationships can provide some interesting insight on restoration. For my next steps, I'm looking to explore how storage volume compares to anticipated runoff, explore how recurrence interval versus storage trends can influence restoration prioritization, and also I am planning to create a restoration prioritization ranking system in GIS in order to model some restoration scenarios. So with all that said, thank you for listening, and I'm happy to take any questions if there is time.
I'm just wondering if you have had a connection with the Lake Champlain River flood study that is happening.
Ooh, yes we have. Beverly says yes we have.
Brian is getting this start.
Mm-hmm.
I think that we would be very interested in your work.
Mm-hmm.
Any other questions?
Mm-hmm.
So
are you actually going to be looking at putting in restoration measures as part of your research? Or is that more of like your research will inform restoration?
Yeah, more like it'll inform restoration. I'm hoping to model some like berm removals and other types of construction like that to see how it influences flooding, but unfortunately it'll just be conceptual for now for me.
Is there public acceptance of the value of that? Like there's got to be demand to continue development in those floodplains
Mm-hmm.
and was there support through zoning boards or stuff that limits,
Mm-hmm.
like recognizing that the floods are becoming more frequent, or are there still pressures moving in the opposite direction of taking away more and more of that?
Yeah, I know the state of Vermont has implemented a lot of measures to reduce the amount of construction and infrastructure that can be put in floodplains currently. So there's a big focus on the state level to try to limit that kind of construction. Yeah. Mm-hmm.
So when you're all done, will you actually try to reach out to the state and give testimony, or go to subcommittees, even ahead of being asked to do that? How do you get the information in the hands of the legislators?
Ooh, that's a good question, and something that I should probably think of doing in the future, for sure. But this is all a part of the Lake Champlain Basin program, so I am doing this in a part funded by the Nature Conservancy. So I'm hoping through maybe some of the partners they can help potentially share some of this data. And I'll be working a little bit with some of the engineers that are doing a project with VTrans to do the restoration prioritization bit. So I'll definitely keep that in mind in the future, because I'd love to share this if we find a lot of it to be fruitful. So yeah, cool. Thanks.